So this recording is about boosting. So what we are doing is that the we are doing boosting on the house data, and the house data has got 21,613 rows, and we are predicting the price. So the first tree that we would be predicting is a very simple tree, and we are predicting the price. So that is a tree 1. And what we do is that we get the errors from the actual price, and this is known as the residuals. The second tree is kind of different. Instead of predicting the price, we are taking the label as the residuals and we are predicting the residuals. So the second tree takes all features except the price. And what we do is that we do a very strange thing. We take tree 1 and then we add tree 2 to it. But here is the problem. If we fit the training data like this, then the tree 2, if it is perfect, then it would solve the tree and we would completely fit the training data. Therefore, it might lead to overfitting. And for this, how do we prevent overfitting? We add a learning rate that is known as the learning rate, and we add to the predictions, multiply it to the predictions of the second tree. So, so this is how what we are doing is that we are preventing overfitting. The next part is that what we are doing is that we are again adding the second tree, uh, that is on the residuals, and we are also multiplying by the learning rate. So that is the first tree multiplied by the learning rate and the tree 2, and second tree is also multiplied by the learning rate. So we are getting a series of trees here. Similarly, for tree 4, we are getting this. Now, what are the hyperparameters? The hyperparameters are the number of trees, the learning rate, and the number of splits in the tree. Now, there is a difference between bagging and boosting. What is bagging doing? Bagging is creating multiple copies of the original training dataset, and it is using bootstrap. It is fitting a decision tree to each copy and then combining all of the trees to create a single predictive model. But boosting works in a similar way, except that the trees are grown sequentially. Each tree is grown using information from the previously grown trees. Boosting does not involve bootstrap sampling. Instead, each tree is fit on a modified version of the original dataset. This completes our lecture on boosting. Thank you. Bye.